Assalamu alaikum. Well, children, in the previous video, you must have seen the solutions of two theorems of this exercise, the last exercise of this chapter. This exercise is based on inequalities, and we have discussed two theorems last time. Converses of each other. The first one was longer side of a triangle has greater angle opposite to it, larger angle opposite to it. And the second one was the converse of this. Greater angle of a triangle has longer side opposite to it. These two theorems we did last time. You must have seen the two solutions in the previous video. We now have the last exercise of this chapter. Theorem number is 8. Theorem number is 8, 6.8, 6th chapter, 8th theorem. The statement you have on the textbook, you can copy that from there. I will read the statement of the theorem. It is the sum of any two sides of a triangle is greater than the third side. A triangle has three sides. The statement says sum of any two sides. Out of the three you have to choose any two and add them. Sum of any two sides of a triangle is greater than the third side. That is the result to be proved. So, to prove this, let us first draw the diagram. We have a triangle. Suppose this is the triangle. Name the triangle as ABC. That is the given. You can write the given part of the solution for this question. A triangle is given. You write a triangle ABC. That is given to you. And then what we have to prove? According to the statement, sum of any two sides of this triangle will be greater than the third side. We may choose the side AB and AC. Sum of the two sides will be greater than BC then. Now instead of AB and AC, you may take the sum of AB and BC. Then that will be greater than the third side AC. Or the third possibility is, if you add BC and AC, the sum will be greater than AB, the third side. That is to be proved. Sum of any two sides, you can write the statement there. Sum of any two sides of a triangle is greater than the third side. Now to prove this, we have to do some construction. And the construction involves producing this BA side to a point P, suppose. You have to produce BA. It should be therefore a straight line. It should not bend here. It has to be produced straight. Now to P point you have to produce. Why it should be that P? You have to make sure that this AP is equal to AC. While you produce BA to P, you have to make sure that AP is equal to AC. If AC is 5 centimeter, this AP also should be 5 centimeter. So I have put two short lines on both of these to show these are equal. And then you have to join P to C also. This is the construction. So you write the construction on your copies therefore. I will dictate, you write. Produce the side BA to the point P such that AP is equal to AC. And join P to C. This is the construction. Now the proof of this. To prove this question, we'll consider first this triangle which has two equal sides. You can identify the name of the triangle is ACP. We'll ignore this part. Roughly I will draw this part of the diagram here. This is the one. I have C here, A here, P here. Its two sides are equal. AP and AC are equal. So this triangle we'll be using first. And then use the result. Equal sides of a triangle have equal angles opposite to them. Second exercise, we have proved this theorem. Let us write this much first. In triangle ACP, we have AC is equal to AP. We have done this in the construction, so write in the bracket construction. And then the result is their opposite angles will be equal. Let us identify those. Angle opposite to AC is at vertex P in the rough figure. We find in actual figure also at P only one angle is formed. Therefore you can write the short name. Angle P will write is equal to. But when we come to the side AP, its opposite angle is at vertex C. Should we call it angle C? No, you have to see in the actual figure. Many angles are formed there with vertex C. Therefore, it will be convenient, it will be better you give full name, and the full name is ACP angle, is equal to angle AC. What the reason? Because angles opposite to equal sides of a triangle are equal. Angles opposite to equal sides of a triangle are equal. This is the reason. Mark this as first result, number 1. Now, having done this, applied this theorem in this triangle, we shall now choose again the vertex C. Many angles are formed there. 3 angles you can easily name. Is angle ACB, angle ACP, angle BCP. 3 angles are formed there. And we find angle BCP, the largest angle, is equal to sum of the two smaller angles there. Angle BCP we say is angle BCA plus ACP. And then the concept as that was explained last time also, in case of numbers, if we have 5 equal to 4 plus 1, instead of 5 we have angle BCP here, the largest angle, is equal to. Instead of 4 I have angle BCA, one of the parts. And instead of 1 I have angle ACP, second part. These two angles together make angle BCP. Then what was the result we used previously? 5 is larger than 4, as well as 5 is larger than 1. So this larger angle, larger number 5 is greater than either of the parts. The reason we used last time was whole is always larger than the parts. Will apply here. The larger angle BCP therefore will be larger than angle BCA as well as angle ACP. It will be larger than both of these. And I shall choose here the angle that is involved in first, angle ACP. You can write, we know angle BCP is larger than, symbol of larger than, angle ACP. What the reason? Because whole is always larger than the part. Whole is always larger than the part. In this result, we'll substitute first. Angle ACP we have already equal to angle P, so we'll replace angle ACP by angle P here by substituting first. We have angle BCP is larger than angle P. This is the result we get from here. Now knowing this, knowing that angle BCP is larger than angle P, this angle, we'll now consider the largest triangle formed in the figure. I shall draw the rough figure here again. This one. Now I have C here, P here, B here. This is the next triangle I will use. BCP triangle. Out of its three angles, we have the relation between two. Angle BCP is this one. We know it is larger than angle P, so these two angles are involved. You write in triangle BCP, we have angle BCP is larger than angle P. We have just now proved it. Therefore, from this, what will we conclude? The result of the previous theorem. Larger angle of a triangle, if you have two unequal angles, one is larger, another is smaller, then the theorem we did says larger angle of the triangle has longer side opposite it. Now you cannot say about angle B, it is not related to any of those. These two angles are related here. Angle at vertex C, angle at vertex P. BCP is larger angle, angle P is smaller angle. Larger angle will have longer side opposite it, that is AB here. Smaller angle will have shorter side opposite it, that is BC here. So therefore, AB is longer than BC. Put the reason, because in a triangle, larger angle has longer side opposite it. Is the statement of that theorem. Opposite it. And finally, this AB will be, sorry, it is BP is larger than BC. I have to see this figure. Angle BCP opposite to this is BP side. Angle P opposite side is BC, so it is BP is larger than BC. Now this BP will split. In the figure, this BP is sum of two parts, AB plus AP. Together these make BP is larger than BC. And then apply the construction. AP we have made equal to AC. AB plus AC is larger than BC. We have used construction here, and that proves the result of the theorem. Sum of two sides, AB and AC are the two sides of the triangle. Their sum is larger than the third side, BC. That completes the proof of this theorem number 8. With this, we can start the exercise. Question number 1 of the last exercise of this chapter. Statement of this question reads, show that in a right angled triangle, the hypotenuse is the longest side. You have a right angled triangle, you draw a right angled triangle. Consider this to be a right angled triangle. Let us name the triangle as ABC. It is right angled at B, and therefore AC will be the hypotenuse. Side opposite to the right angle in a right triangle is called hypotenuse. Now what are we asked to do? We have to show that the hypotenuse is the longest side. Longest word is used. Longer is not used. It is a superlative degree. It is the largest side. Out of the three, therefore, hypotenuse will be the largest. We have to show this hypotenuse is longer than AB as well as BC. That result we have to prove. The right given of this question. What is given to us? As per the statement, you are given a right triangle. You write, therefore, a triangle ABC is right angled at B. This is the given of this statement, given of this question. A triangle ABC is right angled at B. Right, to prove. To prove, as per the statement, hypotenuse is the longest side. This is we have to prove. What we have to prove? The hypotenuse is the longest side. To prove this, let us proceed. Here is the proof. Well, we know a triangle has three angles, and the sum of the three angles of the triangle is 180. This is known to us. Angle sum property of triangle. And then out of the three angles, measurement of one angle is given, angle B. It is 90. This is a right angle. When you use this result in the angle sum property, what will you get? The sum of A and C also will be 90 then. Because then 90 plus 90 will become 180. You write angle B is equal to 90 degrees. It is given. Therefore, sum of the other two, angle A and angle C, will also be 90. This we get from angle sum property of triangle because of angle sum property of triangle. Sum of three angles is 180. If the measurement of one of them is 90, the remaining two will have sum equal to 90. Now this will in turn tell us, as we did in the previous question also, last time also, the sum of these is 90, which means 90 will be larger than both of these. 90 will be larger than angle A, 90 will be larger than angle C also. Therefore, 90 degree is larger than angle A as well as angle C. Measurement of angle A will be something less than 90. Likewise, measurement of angle C will be something less than 90, such that their sum is equal to 90. If angle A is 10 degrees, what will be angle C? 80. So both of them are less than 90. Angle A may be 20 degrees, then angle C will be 70. 20 plus 70 is 90, means both of them are less than 90. Now these will use one by one. If 90 degree is larger than angle A, then we already know angle B is equal to 90. So we'll replace this 90 degree by angle B is equal to angle B. It will become then angle B is larger than angle A. And having done this, angle B is larger than angle A, will apply the theorem. Larger angle has longer side opposite it. You have comparison between angle B and angle A. So their opposite sides you'll use. Side opposite to angle B is AC. Side opposite to angle A is BC. So we'll say therefore AC is longer than BC. Statement is because larger angle, this is the reason, larger angle of a triangle has longer side opposite to it. I got this AC larger than BC by using 90 degrees larger than angle A. Now I have 90 degree also larger than angle C. If we use that part, if 90 degree is larger than angle C, then same procedure. Again for 90 degree we'll write angle B. It will become angle B is larger than angle C. Previously we had angle B larger than angle A. So therefore, we used the result. We used the sides opposite to angle B and angle A. Now this time you have to use sides opposite to angle B and angle C. Opposite to angle B is AC. Is larger than. Opposite to angle C is AB. So you have AC is larger than AB. Reason is same. So what do we have? AC is larger than BC as well as AB. And from that we'll conclude that AC is the longest side of the triangle. And what is this AC? It is the hypotenuse. We write hence hypotenuse is the longest side of the triangle, of the right triangle. Hypotenuse is the longest side of the right triangle. That completes question 1. Now second question. Question number 2. Diagram is drawn on the textbook. Let us copy that. Figure 6.48. This is the figure. A triangle ABC. Then its side AB is produced to point P and the side AC is produced to point Q. Some more information is also given that angle PBC is this angle. Angle PBC, exterior angle here, is smaller than angle QCB. This is angle QCB. Again, exterior angle. PBC is smaller than angle QCB, that is given to us. We have to show that AC is larger than AB. AC we have to show is larger than AB. You quickly write given and to prove from the statement. As usual, given will begin from sides AB and AC up to also angle PBC is smaller than angle QCB, that part is given, and then you have to show that this is the result to be proved. AC is larger than AB. To prove this, let us write the proof. To prove that this AC is larger than AB, we will prove their opposite angles first. We'll prove the angle opposite to AC, that is angle at vertex B, the inner angle, interior angle, is larger than the angle opposite to the side AB, that is at vertex C. We have to show this angle. Let us, for the sake of convenience, name this angle 1, this as angle 2. So we need to show angle 1 is larger than angle 2 to get the result AC is larger than AB. Now to prove this, we are given that angle PBC is smaller than angle QCB, that is given to us. And in that result that is given to us, we have to use one result we have read earlier in the chapter, lines and angles. Exterior angle of a triangle is equal to sum of two interior opposite angles. This result we have to use. We have two exterior angles in the figure. Angle PBC is an exterior angle. Angle QCB also is an exterior angle. Now that theorem says, we have proved there, that exterior angle is equal to sum of two interior opposite angles. So right, we know exterior angle of a triangle is equal to sum of two interior opposite angles. This is the theorem we will be using. Therefore, now we have to apply it here twice. First at vertex B, then at vertex C. Let us first apply at vertex P, at vertex B. Therefore, angle PBC is equal to angle A plus angle 2. Interior opposite angles of angle at vertex B are angle A and angle 2. Angle 1 is not its interior opposite angle, it is the adjacent angle. They have same vertex, same arm. They are adjacent angles. Opposite angles of angle PBC in this figure are interior opposite angles, angle A and angle 2, their sum. We mark it as first result. Likewise, angle QCB, the second exterior angle, it is at vertex C, will also be equal to sum of two interior opposite angles, and this time angle 2 will not be the interior opposite angle. It is the adjacent angle of this. Its interior opposite angles are angle A and angle 1. So it will be equal to angle A plus angle 1. Will mark it second. So two results we got by using this result of our one of the previous chapters. Exterior angle of a triangle is equal to sum of two interior opposite angles. Now, it is given that angle PBC is smaller than angle QCB. This is given to us. Therefore, in this result, we'll use first as well as second. We'll replace angle PBC by angle A plus angle 2 and angle QCB by angle A plus angle 1. So what will we have? Angle A plus angle 2 is smaller than angle A plus angle 1. Angle A on either side will cancel. So what is left? Angle 2 is smaller than angle 1. Angle 2 is smaller than angle 1. These are the interior angles of this triangle. And now this relation will be used to get the final result. We'll now choose this triangle. You write now in triangle ABC we have angle 2 is smaller than angle 1. We proved it just now. Which will mean when we reverse the order, angle 1 is larger than angle 2. And then apply the theorem. Larger angle has longer side opposite to it. Angle 1 is larger and side opposite angle 1 is AC. Therefore, AC will be larger than the side opposite to angle 2. It is AB here. So AC is larger than AB. You will put the reason. Write the reason, the statement of that theorem. Because larger angle has longer side opposite to it. And that is the result we have to prove. AC is larger than AB. That completes our second question. That will do for this day. All right.